Hey, welcome back. Today we're taking a look at nuclear charge, electron shielding, and atomic radius. So starting off, guys, important to know these terms. You're going to hear them quite often, so it'd be good to have them in your mind as to what they are. So nuclear charge is a measure of the strength of the electromagnetic strength of the nucleus. Electron shielding are how many inner shell electrons that you have, and atomic radius is the size of an atom, basically. So think of an atom as a circle or a sphere, and we want to measure how large it is, just like a circle or a sphere. We can do that by measuring the radius. So from the nucleus, the center of the circle, to its outermost electrons, that is the atomic radius. All right, taking a closer look at nuclear charge. So nuclear charge is, again, as we mentioned just a second ago, it's the strength of the electrostatic charges in the nucleus. What does that mean? Well, remember the nucleus is made up of protons and neutrons. And remember that protons have a positive charge, while neutrons have no charge at all. So in essence, the nuclear charge is how many protons are in the nucleus. An atom with more protons will have a greater nuclear charge. That's more positive charges on the inside, pulling those electrons closer in. So our example here, we have beryllium with 4 protons in the nucleus. Here's our beryllium. And then we also have oxygen with 8 protons in the nucleus. 8 protons is 8 positive charges. So that means it's going to have a much stronger nuclear charge. So those electrons, in essence, then, are being pulled in closer to the nucleus. Remember, negative charged electrons, positively charged protons, there's an attraction there. Opposites attract. So more positive charges means we can pull those negative charges in tighter. All right, but that's not the only thing going on. We also have electron shielding occurring. So electron shielding is when you have inner shell electrons that are shielding those valence electrons. So remember from last chapter, valence electrons are the ones only on the atom's outermost energy level. So it depends what atom you're working with. Some are going to have valence electrons way out in the 7th energy level. Some may only have their valence electrons in like the 2nd or 3rd energy level. So all the levels in between the outer shell, the valence shell, and the nucleus, they're all your inner shell electrons. So our electrons are negatively charged, the nucleus is positively charged, so there's an attraction there between the positively charged nucleus and the negatively charged electrons. Here is opposites attract. But, and here's the big deal, the same charge, so like 2 negatives, we see that here, those are going to repel one another. So those inner shell electrons between the valence electrons and the nucleus, those inner shell electrons, they're going to shield the nucleus and actually repel or repulse the outer shell electrons further from the nucleus. We'll take a look at 2 atoms here, lithium and potassium. And with lithium, it doesn't have very much shielding going on. So you've only got these 2 inner shell electrons. So that one valence electron is going to have a pretty strong pull to the positively charged lithium. There's not much shielding occurring at all. On the other hand, here's potassium. Look at all these inner shell electrons. Here's our 1 valence electron. And look, he's blocked from the nucleus by 1, 2, 3, 4, 5, 6, a lot of electrons. Look at all that shielding. All these electrons are blocking or shielding this outer electron, this valence electron, from the nucleus. So his connection, that electron's connection to the positive charge, is not going to be very strong. All right, and that brings us to atomic radius. which is basically, as it sounds like, it's the size of an atom. So we think of a circle. I know it's really a sphere, but if we think of a circle, from the center to the outermost electrons, that's the radius. So there's two trends we're going to look at. The first trend is as we move down a group. So here is the alkali metal group. And as you move down, as you can see, the size gets larger. We're getting bigger and bigger atoms. This happens for two reasons. First reason, as you move down the group, more and more energy levels are added, and so the size of the atom increases. So that should make sense. Lithium only has 2 energy levels. It's like drawing 2 circles. They're not going to be as big as, say, potassium, which has 4 energy levels. So it's going to be a lot bigger just because it has more energy levels. So that's one reason. The second reason that the atoms are getting bigger as you move down is you're adding more and more shielding from those inner electrons. So as we looked at before, if this were potassium, we'd have all these energy levels be full of electrons or filling up with electrons, and that's a lot more shielding. That's a lot more blocking of the nucleus from these outer electrons, the valence electrons, than this atom here would have. He's only got those 2 electrons blocking or shielding the nucleus. So these guys on this level are going to be a lot more attracted, so that means they get pulled in tighter to the nucleus. That keeps it a much smaller atom because those outer electrons are being pulled into the nucleus a lot tighter. So those are the 2 reasons that we see atoms getting larger as we move down a group. The other trend we're going to look at is as you move across, from left to right, across a period. So here is period 3. Moving across, again, here would be our gap in the periodic table. Here's the break between magnesium and aluminum. But as you move across, you can see that the atomic radius decreases. Our atoms are getting smaller from left to right across the periodic table. The reason for this is that we're having a larger and increasing nuclear charge. So in order to see that, let's look back at beryllium and oxygen. These are both atoms in period 2. And as we mentioned before, beryllium only has 4 positive charges. Oxygen has 8. The amount of shielding is the same. So the amount of shielding is the electrons in this inner energy level. That's the red level. That's 2 electrons for beryllium. And guess what? It doesn't change. It's still just 2 electrons for oxygen. So we have a much greater charge, nuclear charge, in oxygen with 8 positives than beryllium with only 4. So these 8 positives are able to pull the valence electrons in a lot tighter than just 4. That results in a much smaller atom for oxygen than beryllium. That's our end result. As you move left to right across a period, you're getting smaller and smaller atoms. So again, to revisit everything, atomic radius increases down a group, and so here we have a kind of a picture of the periodic table graphically displayed with the size of the atoms, the radius. Doesn't matter what group you're looking at, you're getting bigger, you're getting larger as you move down the group. And it decreases, atomic radius decreases as you move across a period. So similarly, if we check out any period we want, left to right, the atoms are getting smaller and smaller as we go across the periodic table. All right, that's our first little bit on trends. So take a look, do your homework. We'll see you tomorrow.